Okay, so here's the description of what we're going to do with the Excel file. I decided, even though we ran 5 runs for this per condition, we're just going to analyze one of them. It didn't take us that long to do 5 runs. So I've opened up Excel, and first we're going to put in the masses. So these are the masses for scenario 1. So mass 1 for me was 0.4951 kilograms. So you measured it in grams, but divide by 1,000. Convert to kilograms. Okay. Now what we'll do is we'll come up with a procedure for scenario 1, but then we should be able to use we should just have to paste new data in to be able to do the other scenarios. So the work is going to be setting up scenario 1, and scenario 2 and 3 should be pretty easy. Okay, so we're going to read in the velocity, scenario 1, velocity 1. So to do that, we're going to go to File, Open. You're going to look for the location of your files that you downloaded. So mine are in Physics, COVID Labs, Lab 6. And you'll see how this doesn't show up the text files. So you've got to go down here to choose all files instead of Excel files. So now you can see your data files. So I'm going to open up scenario 1, velocity 1, run 1. And we know it works out, so we'll just push finish. So we've got our data for what we're interested in. So we highlight the data. We copy it. I'm going to use Control-C. We'll go to the original file we were working on, and we'll paste it, or Control-V. Let's go ahead and save this, give this a name. So the format I want you to use here is, so find somewhere to save it that you'll be able to locate it. I'm going to put it in the same one I had before. And I'm calling this Lab 6 Analysis Steve Nicholson. Now I've already have this created because I started the video and then I realized I had the wrong screen, so I had to restart. Luckily it was only 3 minutes, so I'm going to say save. You won't have to say yes because it won't have existed. So now you can see this is Lab 6 Analysis Steve Nicholson. Okay, so this is channel 1 data, or run. This is the velocity for mass 1. Let's go ahead and close the other one that we just opened because we don't need it anymore. So instead of just opening files, we'll get rid of them after we don't need them. Okay, so we need the velocity for channel 3 and 4, which is the velocity of mass 2. So I'm going to leave a space here, and then I'm going to open, go to my file location. I'm going to look for scenario 1, velocity 2, run 1. So that's the velocity, the second item. Then we highlight the data. Control-C, copy, or just copy it. Go back to the original file, paste it, and let's go ahead and close the data file that we just opened up. Okay, so we were doing 25 samples per second, which would be 0.04 seconds. So if you look at here, it's about 0.04 time difference. Now, for whatever reason, it doesn't start taking one until after about 2 or 3 readings. Maybe it needs to see if it's working or not. You'll notice this one is not the same time as that one. So we're going to have to do the same thing that we did in the previous lab. We're going to have to interpolate to figure out what the velocity is at the same time. And it does make a difference because I tried it where you just said, oh, that's close enough, and it doesn't, it shows inaccuracies. Now, the first thing that we're going to do is we are going to, let's just look at velocity versus time for channel 1. So to do that, we'll highlight the two columns. We'll go to Insert and choose the scatter chart. So there it is, okay? Now, what's happening here is that I push the cart, then it's slowing down, then it runs into the second cart, and then it stops. Okay, so that's what's going on. Now, I really don't care about this first part. What I'm looking for is this, the collision, and after the collision. Now, I don't want to go too far back because I don't want this part. So we're going to set a rule here. Is we're going to find out the time this collision starts, which you can see if I go up here to the data. You can see for velocity here, it's 0. Then it becomes positive. Then it's positive. This is where I let go. It's slowing down slightly, and then you see this quick drop off right here. So it goes 0.56, 0.55, and then all of a sudden 0.42. So I want to go 15 cells up this way and 15 cells the other way for a total of 30 cells. So we're going to do 15 before and 15 after the collision. Actually, how long does the collision happen here? So actually let's go 15 up, and we'll do 19 the other direction because it's about four data points that are in the collision. Okay, so what we're going to do is we're going to get rid of the data that we don't really need. So look approximately where the thing starts to drop off. Put your cursor there and count 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you can look at the velocity. You can see it's a high value. Okay, so go one more, and then highlight all the data to the top. Then right-click, pick Delete, choose Shift Cells Up. So what that does is it moves everything to the top. Okay, go back down to that same point where the velocity starts to drop. Count 19 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, and then highlight those cells to the bottom, and then right-click, delete, shift cells up. There we go. So if we go back to wherever the chart was, where did the chart go? Oh, so you can see that I've just got data before and after the collision. So that's what I'm looking for. Now I don't need this graph right now, so I'm just going to highlight it and push delete. That was just to demonstrate what we're doing. Okay, so now what I would do is I would delete all of the data here up until the first number that is just less than this one, 1.416. So let's look for something less than 1.416. So 1.4, so that would be it, 1.416. So we're going to highlight that, click delete, shift the cells up. So you can see I've got 1.416. Uh-oh, I went too far. This is the best friend is to use this undo key. So I need to redo that. I should have gone one less, 1.416. So I should go to right there, 1.4057, then delete, shift the cells up. So you can see I've got 1.4057, which is less than this, and then I've got 1.4454, which is the other side. And then I can just wheel down and probably just delete where do I want to go here? I think I want to go to here and get rid of the rest of this data. Now notice these velocities are positive. These are negative. So I have to reflect that when I do my calculations. But I'm not going to change them. I could multiply them by -1 and then replace them. Let's not worry about that. So this space I left in here is to calculate the velocity. This is let's copy this. Control C, Control V. And the difference is this is the interpolated value. So what we're trying to do is figure out what the velocity is here based on these velocities there, these two. That's why we needed the extra row here. So we talked about interpolation. I'm just going to show you the formula. So you take the value of the velocity to start with at the earliest time, which is 1.0457. To that you add the difference between the velocity at the higher time and the value of the velocity at the lower time. This is the difference in the velocity between those two time points. Then you take the time. So what we're trying to do is we're trying to interpolate to this time. So you take that time, subtract the early time, right parenthesis slash, then you take the later time here, which is, am I doing this right here? Yeah. Take that one and subtract. It's hard to get it in there because there's this space. Let me stretch this. Yeah, it won't let me do it. I may have to just type it in. D5, right parenthesis. Okay. So it's taking the velocity this time, adding the difference, the percent of difference between these two that's associated with this time period here. So you can see 1.416 is closer to 1.407 than to this. So it should be closer to this velocity than that velocity. Now, since they're both 0, you don't see anything happening. But now that we've got it in as a formula, we can just drag this down. And we'll get these interpolated velocities. So for example, at 1.9647, the velocity is 0. At 2.0047, it's negative 0.01. We're looking for it at the time 1.951. So it should be between these two values, but it should be closer to this value than that value, which it is, 0.0026, which is about 25% of the way. And most of them should be about that percent because you're all offsetted by about the same amount of time. So these velocities now correspond with these times. So that's good. So now we can go ahead and calculate the momentum for cart 1, the momentum for cart 2. We can do the total momentum. Let's actually put that in 2 lines. So just put total in one line and momentum in the second line. I'm going to double click between these cells so you can see the entire word there. We're also going to do kinetic energy. So we'll go kinetic energy cart 1, kinetic energy cart 2 total kinetic energy. Okay, so how do we calculate these things? Well, we just have to do them for the first row, and then we can copy of them all. So the momentum for cart 1 is equal to the mass of cart 1, which is there. Push F4, because that doesn't change, times the velocity for cart 1, which is that cell. So that's the momentum for cart 1. The momentum for cart 2 is equal to the mass of cart 2. Push F4, multiply by the velocity. But actually what we're going to do is we're going to multiply negative by the negative because these velocities are negative. But relative to the same coordinate system, they're actually both positive. So that's just compensating for that. And the total momentum is just the sum of the two momentums. Okay, let's go over to the kinetic energy. So the kinetic energy for cart 1 is 1/2 times the mass for cart 1, push F4, times the velocity for cart 1, which is here, squared. Okay, so that's kinetic energy for cart 1. Kinetic energy for cart 2 is 0.5 times the mass of cart 2, push F4, times the velocity for cart 2, which is in column C, squared. So you can see cart 2 has 0 momentum and 0 kinetic energy to start with because it's just sitting there. Now if we highlight all 6 rows there, find the right-hand lower corner, drag that down to here, we'll get this. So you can see the momentum of the cart is going down because its velocity is going down. Now I wish we had more significant figures here. We've only got 2 significant figures, and I'm not sure if there's any way to get more. Now the momentum should be continuing to go down kind of gradually. And the kinetic energy, you should see a decrease in the kinetic energy. Oh, I forgot to do total kinetic energy here. Let's do that. Let's take the kinetic energy of cart 1, add it to the kinetic energy of cart 2, and copy the formula down. Okay. So let's plot these things out. So what we want to do is we want to plot total momentum versus time, and total kinetic energy is a function of time. So probably the easiest thing to do is to, it's going to automatically choose which columns, and it's not going to choose column A and column I. So we might just choose column 1 and 2, because at least column 1 is the time. And then we'll go to Insert, Chart, Scatter Plot. So you can see it's showing velocity. That's what we looked at earlier. You see the velocity of cart 1 going down gradually for friction, then going suddenly for the collision, and then being essentially stopped. Let's put this in a separate tab. So we'll right-click. We'll say Move Chart. We'll pick a new sheet, and we'll call that Momentum Graph Scenario 1. Now this is not what we want. We want momentum. So let's go up to Select Data. And if we do Edit, we want the X values are fine. We just want to change the Y value. So we'll click on the Series Y value arrow. instead of column B, we're going to go over to column I. We're going to highlight the data, push enter, say OK, and then say OK. So you can see it, the momentum is gradually going down. We really can't tell where the heck the collision happens. We've got these little things that are kind of blips, and I don't really know what those are caused by. You'll also notice that the y-axis goes from 0.24 to 3, which it's showing a huge change here, and it's not, ideally you'd have conservation of momentum. It would be a horizontal line. So we're going to do a few things. We're going to clean this chart up first. So first, there's no point in having this big blank space here. So you can see that the data starts here. If I put my cursor on a data point, you'll see that it gives you the data values. It says 1.4. So let's write that down, or you'll write yours down when you do it, but whatever that first time is. So I'm going to write down 1.46. I'm going to go to the data point at the end, which is 2.73. So what I'm going to do is we're going to go from a time of 1.4 seconds, which is slightly a little smaller than the first reading, to 2.8 seconds, which is the next one up. To change the scale, you go down and click on a number in the x-axis. You right-click and you say Format Axis. So we can change the bounds here. Right now it's under Auto. So we're going to change the minimum to whatever the value you have that's just before the collision. Mine is 1.4. You'll have to decide what yours is. It automatically chose 2.8, but I'm going to go ahead and manually put in 2.8. So what that has done is it's now spread out the data so we can see more of it. So I'm going to go ahead and close that. Now for the y-axis, we're going to go from 0 to 0.3. So we'll click on a number in the y-axis. We'll right-click. We'll say Format the Axis. Here it's Auto. So we're going to go from 0 to 0.3. And so you can see how the momentum is reasonably constant. You do get this little blip there and a little blip there, but they don't look quite as big. And actually, this is really high up, so I think I'm going to change it to 0.35. The more I make this upper number bigger, it's going to move this thing down the chart. Okay, so that looks good. So we've given the tab a name, but let's go ahead and put a title. It's the same thing, Momentum Graph Scenario 1. And let's go ahead and how do we get, so click on the graph, do this little plus sign. We want to have axes titles as well. I think that's it. Okay. So let's go down to the x-axis. The x-axis is time. Units are seconds. The y-axis title is momentum. So momentum, the units are mass times velocity, so it's kilograms meters per second. Let's see. These look a little small, so I'm going to click on the titles, go to Home, pick some bigger fonts so I can see them a little easier. So I'm going to use 14 font. The title probably should be a little bit bigger, so we'll make that 18. And the numbers, the axis numbers are a little small too, so we'll click on the axis and we'll go back up here to font, pick 12. Same here. Click on the y-axis, pick 12. So that looks pretty good. So you can see the momentum is pretty, it's just decreasing because, not because of the collision, but because of the friction. Now, what we want to do now is we want to do kinetic energy. But instead of going through every step again, we can save some time. And let me show you how to do that. So if you right click on the tab down here, choose move or copy, say create a copy. Now I've got momentum graph scenario 1, momentum graph scenario 1. So we're going to change this graph into kinetic energy. So what we'll do is first we'll change the name. So double click on the tab, change momentum to kinetic energy. Oh, doesn't like, that's too long. Kinetic energy, and get rid of this little 2 thing at the end because that was telling it was a copy. But okay, so that's kinetic energy. Now if we click on the graph and go to design, select data, we're going to edit the series, and the y value, instead of being the momentum, is now going to be, we'll go to the column that has the kinetic energy, which is this last column here. So we'll highlight the stuff in column M instead, and push enter, say OK, OK. So the time's fine. We need to change the labels. So let's change the title. Kinetic energy, do that over here as well. So instead of momentum, we'll have kinetic energy. The units are joules. We could say it's, what is it? Kilograms meters squared per second squared, but energy is joules. Okay, so we got kinetic energy, graph scenario 1, we got time. What I want to do is change the scale on the y-axis, so we'll click the y-axis, right click, format axis, and change the upper bound to 0.1 instead of 0.35. So there it is. So what you see is that the kinetic energy is decreasing because of friction. Then we have the collision. What's happening here is the energy, the kinetic energy, is being stored in the spring or in the magnetic field. But then when the carts start to move apart again, the energy in the magnetic field is recouped into kinetic energy. So if I were to just draw a straight line through here, it should go straight. You know, we're following the same trend of decreasing kinetic energy with time. We just have this little blip during the collision where the energy is stored in the magnetic field. So that all looks perfect. While we're thinking about it, let's change sheet 1 to, let's call that data. So we need to, so that's the first tab's data. Okay, so that's scenario 1. And actually, let's double click on data and say SC1. So what we're going to do now is scenario 2. So the way we're going to do that is we are going to create a, we're going to copy this data scenario 1 file. So we'll right click on it, do copy, choose copy. Here's data scenario 1, 2, which means it's copy. We'll double click on there and we'll change it to data for scenario 2. We haven't put that in there yet, but we are going to do it. Okay, so that's data for scenario 2. So we need to get our scenario 2 data. We're going to put it here, these two columns, and we're going to put it in these two columns. But we're going to make them have the same number of entries, so everything's going to align up correctly. So we're going to do that in a separate spreadsheet, and then we'll copy it in when we get to that point. So let's see what we're going to do. We're going to, let's save the file just to be on the safe side here. So do File, Open, Browse. So now we're going to Scenario 2, Velocity 1, Run 1. Save, Finish. Then we will go File, Open, Browse, Scenario 2, Velocity 2, Run 1. Finish. Now we're going to take the data here, 3 and 4. We're going to copy that into the first file that we had here, Scenario 2, Velocity 1, Run 1. And we're going to, we don't need to, well, we'll leave a space. So Control V. We'll come down, find out where the collision occurs. So the collision here occurs at 1.6696. So we said we were going to go 15 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's delete everything above that. So highlight it, right click, delete, shift cells up. Then we'll go down to the collision again. Where's the collision? Oh, here's the here's the collision right at row 18. We'll go 19 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's delete everything after this. So highlight it, right click, delete, shift cells up. Okay, so that's good. Now, if we go back to the original one, this was the velocity that we had. So we wanted this column, the second group of numbers, we wanted to have a time that was just less than the time that's in the upper left-hand corner there. So if we go, we've got 1.0982, 1.0187. So that's the one we want to delete everything before that. So we'll highlight those cells, right click, delete, shift cells up. So you can see I've got 1.0872 and 1.0982. And then I'll go down to the bottom and I'll delete everything. I need to leave one more piece of data in this column. Okay, so again, let's show what we're doing here. This number is slightly less than that number. This number is slightly less than that number. So everything's perfect. Okay. So now we're going to copy these two groups of data into the original file. So I'm going to highlight this data, do Control C, go to my Excel file, and I'm going to replace the data that I have here. And let's see, how far does this go down? Cell 38. So let's see how I did. If I get one extra, it's not going to be the end of the world. 39. Yeah, so I could get rid of one of these. So I'll just copy one less column, one less row. Okay, then I'll go back to the one with my new data. I'm going to highlight all the way down. I'm going to leave off one row because I deleted it here. Control C. Go back to the original file here. Replace this data. Control V. I also need to change my masses. So for scenario 2, M1 was 0.4969, and mass 2 was 0.4987. So that is my data for scenario 2. And I've got my momentum, I've got my kinetic energy, I've got everything. So what I can do is I can take the graphs that I already have put together so I don't have to redo everything. So I'm going to click on Momentum Graph Scenario 1. I'll right click it. I'll create a copy. And I'm going to drag this over closer to my data. So here's Scenario 2 data. Here's my graph. So what I'm going to do is I'm going to use the graph from Scenario 2 instead of Scenario 1. So let's first change the title to Scenario 2. What else do we need to change? We need to change the title here, Scenario 2. And then we need to change the data. So to do that, you highlight the graph, you go to Design, select Data. Now, if you look up here, it says Chart Data Range, Data C, Scenario 1, blah, 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 data Scenario 2. If I just go up here and click and change the 1 to a 2, because I've got the same naming strategy. So I don't even have to go into I don't even need to go into the spreadsheet. I can just change the range of data. And there it is. Okay, so if I do that just to show you it actually worked, select data, edit. If I click on like the Y value, it's going to go into data Scenario 2. So it did do it correctly. So I'll just cancel that. Okay, so that's momentum. It looks very similar to the graph for momentum series. It was pretty constant, even right through the collision. There's one thing we need to change is the time, because I think I've chopped off the time. So let's go to the Data tab and see what times we're looking at here. So you can see we were from 1.09, so I would go from 1.0, and then I'd scroll down here and say go to 2.5. So then now that I've got, because the collision doesn't happen at the exact same time, so we'll go to Momentum Graph Scenario 2. We'll click on the x-axis. We'll right-click, choose Format Axis. Instead of going from 1.4 to 2.6, we'll go from 1.0 to 2.5. And there. So now we've got all the data. I chopped some of it off earlier. So let's double check everything. Momentum, time, we've got the tab correct, we've got the title correct, we've got the correct data in there. Okay, we're going to do the same thing for kinetic energy. So we go to kinetic energy Scenario 1, right click, move or copy, create a copy. So now I've got kinetic energy graph Scenario 1, copy 2. I'm going to pull this, drag this so it's over with my Scenario 2 data. I'm going to double click on the tab, change the title because now it's Scenario 2. Got that. Go up to the graph title, change that to scenario 2. And finally, well, we could change the x-axis because that's going to be the same. So highlight the x-axis, right click, format axis, go from 1.0 to 2.5. And I don't know what. Oh, it's because we haven't changed the data yet. Okay, so now we're going to change the data. Click on the graph, go to design, select data. So again, we're going to go up to this chart range data, change SC1 to SC2, change SC1 to SC2, say OK. And I probably will change the kinetic energy scale. So let's go to from 0 to 0.7. So we click on the axis, right click, go to format axis, make the upper value 0.07 or whatever fits, makes your graph look a little better. So what you can see here is the kinetic energy slowly decreasing. We have the collision, the energy stored in the spring, but notice if I were to project this without any kinetic energy loss, it would have gone something like that. But you can see how we have a loss in kinetic energy predicted compared to where we had it for the perfectly elastic collision. So if we go back and look at scenario 1, you can see how this kind of just goes straight through. I could project this straight through, and this is just a little blip. Whereas for scenario 2, if I project it through, it would go here. So we have this loss in kinetic energy. Okay, so that is scenario 2. Now we're going to do the same thing for scenario 3. So how do we do that? Well, we need the data. So we'll click on data scenario 1, right click, move or copy, create a copy, say OK. So that's a copy of scenario 1 data. We will double click on there and we'll change it to scenario 3. Okay, we don't have that data yet, but we'll get it in just a second. So we do exactly the same thing as we did before. Let's go ahead and close these data files that we had opened up. Let's go ahead and save the Excel file. Let's scroll to the left. So again, we're going to replace columns A and B and columns D and E. So let's open. Let's go to scenario 3, run 1, velocity 1. Let's go to scenario 3, velocity 2, run 1. Okay, first thing, we're going to copy the data into one file. So we're going to leave the space because we're going to do that interpolating thing. Actually, that reminds me, did I do that? Oh yeah, it does it automatically. Okay. Okay, again, we're going to look for the place where the collision occurs. So, okay, I was like, what's going on here? So the way to do this is just trying to figure out where things are happening. Yeah, it looks like you can see here's where the collision is happening. It's just surprising the velocity is not going down as much as I expected it to. Don't really know why that is the case. Because, you know, you can see they're matched up here. One's positive, one's negative, so they are traveling together. Here it's 0, and then there's the collision. But it goes from 0.27 just down to 0.24, which doesn't seem reasonable. So I'm going to, yours may look reasonable, but mine doesn't look reasonable. So I'm going to look at run 2. You see anything that doesn't look right. So let's delete this file. Let's delete that file. Okay, so let's take run 2. Open, browse, scenario 3, velocity run 2. I think, well, let's see what happens here. Check out run 2. Velocity 1, run 2. So here it's going 0.7, and then it drops down to 0.32, so that looks reasonable. Let's open up another one here. Open. So this is scenario 3, velocity 2, run 2. Open that. Say finish. Let's look at that. That starts off at 0 and ends up at about 0.2 something. Does that match up? Yeah, okay, so that looks better. Okay, so now we're going to oh, okay. Yeah, it says run 1, but they're all run 1 as far as our terminology. So let's get the velocities out of the second file, the channel 3 and 4 velocities. Control C, go to this one. We'll leave a space just so we can keep them apart. Control V. I'm going to go ahead and close this extra one that we have. We don't need that anymore. Okay, so let's look for the collision. So you can see it's right here. This one's slowing down. This one's speeding up. They end up with the same velocity but negative signs. So we'll say this is the beginning of the collision. So we'll count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'll highlight above that. Right click, delete, shift the cells up. We'll go to the beginning of the collision again, which is right here. We'll go down 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Delete below, right click, delete, shift cells up. Okay, so we got enough data points. Then we look for this time, 1.1382, and we find the time just less than that, 1.1382, 1.13. So this one is just slightly less than that. So let's delete all this above. And then we'll come down, we'll leave one extra row. Delete those. Shift up. Okay. So again, you can see this number is slightly less than that number. That way we can interpolate. Okay, now we're going to move this into the main spreadsheet. So we're going to highlight this data, cart1 data, Control C. We're going to go to the original spreadsheet, which is this one. We're going to paste it here, column A, like that. We're going to do the next one in column D. So let's go to here we're going to take the second grouping of data, highlight that, Control C, Control V. Let's go down. Yeah, I think we have one extra row of data again, so I'm going to go ahead and delete that. Delete that. So now this velocity here in this column C has been interpolated. So it's at the same time. Everything else is done. I mean, that's all we have. Oh, we got to change the masses. So the masses of the carts for scenario 3, 0.4993, 0.4985. Again, you're going to use the masses that you measured. Okay, so we've done that. We replaced column A and B, column D and E. We put in the new masses, so everything's great. Where are we going to put scenario 3? Let's just drag it all the way to the right here. Okay, so we got that. Now we need the two graphs. Now, since these two are the closest, I'm just going to pick those. So momentum, it's graph 2, scenario 2, right click, create a copy. So that creates, let's undo that for a second. I'm just going to show you something here. So click on the graph here, right click, move or copy. So what if you push create a copy and you move this to the bottom, it'll put it right next to this tab instead of me having to drag it. So you can see now it's right where it needs to be. Okay, so it's still using the old data. So again, what we did, we're going to have changed the title of the tab. So now it's scenario 3. Change the title of the graph. Let's change the time scale. So let's go back and look at our data. So you can see our lowest time is 1.1382. So I'm going to go from 1.1 seconds. Then we'll drag down to the bottom here to 2.5, which is pretty close to what we had. We could actually leave it the same. We're probably okay. So well, for you may have to change it. So let's go ahead and change it. So highlight the time, right click, format axis, change it to whatever makes sense, 1.1, 2.5. So now I've got the time scale slightly changed. So I've got the title here, I've got the title of the tab. These are okay. I've adjusted the X time scale. Click on the graph, go to design, select data. And again, we go up here to the chart data range and we put SC3. That's the advantage of them being exactly the same because they're all indexed correctly. Okay, so I'm going to have to adjust the momentum here. So if yours is fine, that's fine, but I need to increase it. I guess probably because we hit them together harder, so they had a higher initial momentum. So I'm going to go up to 0.5, I think. Format axis, 0.5. So again, you can see that the momentum is going slowly down, but you don't see any collision. Now we'll see a difference here if we do kinetic energy. So let's click on the kinetic energy, right click, move or copy, put it to the end, say OK. So there it is, the copy 2 of scenario 2. So we're going to double click on the tab title, change it to scenario 3, which is my inelastic collision. Change the title of the graph. The time, we're going to change that so it agrees with the momentum graph. The momentum graph went from 1.1 to 2.5, so I need to click on the x-axis, right click, format axis 1.1. So that's good. And then we need to change the data. So we'll click on the graph, go to design, select data, go to the data range here, pick SC3. Say OK. And what happened here? Oh, it's because I need to increase the scale. This data is off the scale. So okay, so I need to change the scale. So let's go to the data and find out what we need to do. So if we look at the kinetic energy column, you see it, the maximum is 1.2. So we'll go to 1.3. So we'll click on the y-axis scale, right click, format axis. What did I say, 1.3? Oh, that put in the wrong place here. What did I use for the lower? I forgot already. Oh, okay, went all the way to 0. Okay, so it's from 0 to 1.3 or 0.13. Okay, so there we go. So if you look at the momentum, pretty much constant through the whole thing, but you see this stark drop in kinetic energy because of the inelastic collision. There's no energy stored because there's no spring or there's no magnetic field. It's just a sharp drop in kinetic energy. So here we're losing kinetic energy because of friction. Then we have the collision. We lose a lot of energy, and then we decrease slowly again because of friction. So I think that's it. That turned out pretty good. Let's kind of review what these three scenarios were. So we're looking for scenario 1 here. Momentum, scenario 1, slowly decreases because of friction. Kinetic energy decreasing, then its energy is stored in the magnetic field and then recouped after the collision. Scenario 2, momentum gradually decreasing. You don't really see a collision. Kinetic energy gradually decreasing. During the collision, energy is stored in the spring, but because the spring is not ideal, we lose some kinetic energy. Finally, the inelastic collision, gradual decrease in momentum because of friction. Kinetic energy, big drop through the collision. Gradual drop before and after the collision.